I just finished competing in the educational Codeforces Round 100, and in this stream I'm gonna go over the problems and just kind of talk about them a bit and answer any questions that you guys post in chat. So yeah, I'm probably gonna wait a few minutes just because no one's really here yet. Maybe I'll do some advertising in the round. I wanted to say I got all the problems right, but honestly, I don't know if my things are actually gonna pass. Okay. No, that's not Russian. Okay, looks like we got some viewers online. Hey everyone, welcome to the stream. How was the contest for y'all? It's an interesting format because of the educational open hacking phase. So these standings could very well change. I have some incentive to try to hack the people above me. That would be funny. But yeah, I'm just gonna wait another couple minutes, see if other viewers show up. And then I'll start talking about the problems, starting from probably problem A, but happy to take suggestions in chat. Yeah, reading a geothermal submission. It looks like he is doing something, can't tell what he's doing, but he's using go-tos, so that's always fun. Yeah, I don't actually know how his thing works, but I think he's doing the same thing as me, just looking at the code here. Yeah, that problem F was very challenging. And problem E was also no joke. I agree, yeah. Hardest of all the ED rounds. Yeah, that might be true. A lot of these problems are very hard. So yeah, I'm probably gonna start discussing the problems from A. I'll start at 8:40, and then we'll go through A pretty quickly, and then I'll talk about B and C, etc. And if you have any particular questions about the problems, like for example, like how do you think about this sample case or something, please post them in the chat. I'll be reading chat. B was bare hard until you figured it out. Yeah, B, all these problems required some kind of insights or the other. All right, so yeah, let's start talking about problem A, dungeon. You're playing a computer game in which you have to fight monsters. In the dungeon you're trying to clear, there are exactly 3 monsters. So there's always 3 monsters, and they have A, B, and C health. So yeah, the way the game works is to kill the monsters. You can either, you can fire a shot at one of the monsters and it deals 1 damage. And then every 7th round, you're gonna hit everyone. So you're gonna do 3 damage total. So immediately you realize this insight, and let me pull up my code for, let's just have a scratch pad. So A, insights, So every 7 rounds, you do 6 plus 3 equals 9 damage total. So yeah, 9 damage total for 7 rounds. And they want you to kill all the monsters at the same time after some multiple of 7 rounds. So total number of rounds equals total health divided by 9 must be an integer. Let me know if that makes sense so far. The sum must be a perfect multiple of 9, and then that tells you the number of rounds. And finally, you have to be able to do that much damage to every monster without it dying too fast. So if k equals total health over 9, all monsters, A, B, C, must have at least k health. So just check these conditions, print yes if true, no otherwise. So yeah, that is how I thought about problem A. I guess the main insight is realizing that 1, the total number of rounds is fixed because your damage output is a constant, and then 2, if every monster has enough health, there's always a way to spread out your shots so that they all die at the same time. So yeah, that's problem A. Any brief questions? Will you upload this to YouTube? No, I probably won't. Maybe I'll think about it. If a lot of people in the chat want me to upload to YouTube, I'm happy to do that. Is Neil not streaming because you are streaming? Just curious. I didn't ask him if he was, I didn't find out if he was going to stream or not. I asked him and he didn't reply. But yeah, he said he's not streaming today because he's been doing it a lot recently. So that's why I'm doing it. Yeah. Let me see what other questions in the chat. Twitch deletes after 4 days. Okay, 14 days. Yeah, okay. I'll upload to YouTube. So that will probably help anyone who missed my explanations for the early problems. Line 5. For problem A, explain again. So, the idea here is, since you're doing a constant damage output and you know ahead of time how much health everyone has, that's A plus B plus C. You just do A plus B plus C divided by 9, and that's how many rounds you're going to need. Rounds of 7. So, given that, you know you're going to do at least K damage to every monster, and that's only possible if they all have at least K health to begin with. So in other words, you have to check that this condition is true. Check that this is true. Because if this isn't true, then before K rounds are up, one of the monsters is going to die already, and then it won't make any sense. You won't be able to kill them all at the same time. So yeah. 9 damage total is because in the first 6 rounds of 1 damage each. 7th round, you do 3 damage. So yeah, that's problem A, scratch. I'll leave these notes up so you guys can keep reading them if you want to, but I'm going to move on to the next problem just so we can get through all of them. I'll try my best to be beginner friendly. This is educational Codeforces round, so I want to kind of focus on the easier problems because those are the ones that, probably are where most of the viewers are at. Combo Thermal, congrats on the last minute F-solve. Thank you, Combo Thermal. I'm assuming you are related or equal to geothermal. That was a hard problem. Well, I'll be talking about it in a bit. It looks like your solution is using the same ideas. I looked at your source code. All right, so find the array. This is problem B. So you're given an array, and you want to make it beautiful. And the way you make it beautiful is you can change every element of the array arbitrarily to another number. such that all consecutive, every pair of adjacent integers in your new array, one of them divides the other. So yeah, problem B was really tricky for me. It took me a while to come up with the idea. At first I was thinking, okay, can we just make them all like either 1 or not 1 and just like turn every other number into a 1? But I couldn't get that to work with the constraints. Let's see. Yeah, I couldn't get that idea to work with the 1s, and then I was thinking, okay, maybe I can do something around like x and 2x, like make everything either x or 2x, but I couldn't get that to work either. Because this condition with 2 times the sum of the differences between a and b, like that's actually a kind of tricky condition to work with if you don't make your transformations relative to the number itself. Like it's very hard, I think, to say ahead of time that your array of b is just like a constant number of values. So yeah, in the end, my insight, and this is a spoiler, you can satisfy a stronger condition. All elements can be divided by all other elements. So instead of bi divides bi plus 1, or it's bi divides bj for all ij. So yeah, you can actually satisfy this much stronger condition, which is all pairs of elements are like factors of each other in some order. And the way you do that is, and this kind of blew my mind, but make everything a power of 2. So yeah, if you make everything a power of 2, it turns out that all powers of a prime divide or are divisors of all other powers of the same prime. So for example, if one of the numbers becomes, like if the original array was 1, 2, 3, 4, 5, you can make this 1, 2, 2, 4, 4, and now everything divides everything else. And another example is 3, 4, 8, 1, 2, 3, and this becomes 2, 4, 8, 1, 2, 2. I'm just rounding everything down to the nearest power of 2. Let's read the chat, see if there's any questions here. Yeah, please upload to, I will upload to YouTube. I'll paste my YouTube link somewhere. Let me just pull that up really quick. See any other questions in chat? Wouldn't it be just s mod 7 equals 0? Oh, for problem 1, no, not quite. Combo thermal, thanks. Yeah, my F, I was scrambling at the end. It almost didn't go. Oh, aria man x. Calculate the sum of all numbers at odd positions and the sum for all even positions. Whichever is lower, set the elements of that to 1. Oh, that's really smart. That might work, but because like you still have that 1, right? So you're not setting it to 0. So it might still cause you issues. But that sounds really close to working. Oh wait, no, that does work. Yes, sorry, that does work. Because 1 helps you. It makes your sum smaller. Okay, yeah, aria man x, your solution is much better than mine actually. Just set either all the odds or the evens to 1. I did not think of that. But I fortunately found another solution which is maybe a bit overcomplicated. Yeah, okay, alternative solution, which I didn't come up with. Set either all even or all odd indices to 1, whichever is smaller. . And this is guaranteed to be less than half the total sum. So sum chosen is, so sum else chosen minus 1 is even more guaranteed to be less than half. Okay, yeah, so the alternative solution is just alternate between AI and 1, as many people said in the chat. I really should have thought of that, but thanks for showing me that solution. My solution of rounding everything down to the nearest power of 2, this satisfies the 2 times the condition with moving elements by at most half their original value. So yeah, by moving each element by at most half their original value. Because the nearest power of 2 is always, nearest power of 2 is always at least half your value. This is because the greatest power of 2 less than x is always at least x over 2. This is because 2 to the I, for all x in the range 2 to the I plus 1, x is less than 2 to the I plus 1 by definition. Yeah, so my solution, I think that counts as a proof, which is, you proved 2 parts, I guess. One is that once you make them all powers of 2, the condition of divisibility is satisfied, and that should be fairly straightforward because powers of 2 divide each other. And the other condition is that you don't move your elements by too much, and that's satisfied because you're picking the greatest power of 2 possible. That's less. You could also pick the first one that's greater than or equal to. Even just the first one that's greater than, that's, oh no, sorry. You have to pick the one that's less, or else you might run into issues. YouTube channel name, I just posted it in the chat. This is where I will be uploading this video after the stream. So, yeah. Check out my YouTube channel after this. I don't have too much content there yet, but I'll probably start uploading stuff soon. Yeah, am I missing any things in chat? Let me read quickly. Can I prove my solution? Yep. And take the closest. Yeah, you always want to take the closest one, which will it won't always be the one less than you, but you might as well just take the one less than you because you're guaranteed that that's at least half. Alright, yeah, if there's no other questions on problem B, I'll probably move on to C then. B was a fun problem. I did overcomplicate it a bit, but fortunately the code is roughly the same length. You can read my code here. I use while built-in pop count is greater than 1, I_n equals I minus 1. This could also be I left shift built-in CLZ I, or I equals 1 that. Or maybe 32 minus that. Okay, never mind. But yeah, you can use your built-in functions to really speed up this part, and that's what I did with built-in pop count. Just as long as it's not a power of 2, drop the clear the lowest least significant bit with this bit magic. Built-in pop count counts number of ones in binary representation of I. And yeah, that's a built-in function that takes a double underscore in the front, and it'll tell you how many bits your number has on. So if it has exactly 1 bit on, that means it's a power of 2. Otherwise, it's not a power of 2. So yeah, that's how I implemented the solution. I used a while loop, and this while loop is guaranteed to terminate after at most something like 30 iterations, because every iteration you're clearing a bit. So this kind of like loop control variable is decreasing by 1 every iteration, so it'll always terminate. Yeah, log 2 is probably smarter, another way to do it. But yeah, I also use ampersand I. This is a reference to v sub I, to an element of v. So that means when I change I, I'm actually changing the contents of my vector, which is why I can actually print out the answer in a separate for loop. So this is another little implementation trick that I used, so I didn't have to think about indexing into my vector. I didn't have to think about n very much. I just created the vector size n and never wrote n again in my program. So that's another implementation trick that I wanted to show off. I use it for reading input as well. So yeah. Let's move on to problem C. Seems like people are talking about it already. It was a fun problem as well. Busy robot. And yeah, this problem, it's about a robot. At time 0, it's at 0, and then you give it n commands. So I think one of the more challenging parts of this problem was just like the kind of novel or it's like a novel setup. The setup of the problem is a bit, it's a bit unfamiliar, because most problems about robots don't have this mechanic of being able to ignore your commands, or like having to ignore things. So I think that tripped some people up. It tripped me up for sure. I was like getting confused, like, okay, what is it asking me again? Like, what is the successful command? I keep forgetting. But apart from that, I think the implementation was also not straightforward at all. So yeah, let's talk about this problem in a bit more detail now. You have n commands. Each command is a pair of integers, t comma x. All the commands are given in increasing order of t, strictly increasing, in fact, and that's written down here. Commands are ordered by time, so ti is less than ti plus 1 for all possible I. So the first thing that should tell you is that you can kind of just process the commands in order. You don't have to do any offline, or very little offline processing. And now the second, let's continue reading the problem statement. Whenever the robot receives a command, it starts moving towards that point and stops when he receives that point, when he reaches that point. And he goes at 1 unit per second. And however, if the robot is currently moving, it's going to just ignore this command, as in it doesn't hear you because it's too busy moving. Okay, so the robot is very single-threaded. It will ignore any interrupts if it's in the middle of doing something, and that is pretty reasonable for a robot to do. And then here's an example, 3 commands. So I'm going to go back to my notepad and see. Let's just work through the example. 3 commands, 153064. So sample 1. There's 3 commands. The first command is time 1, move to 0.5. Okay. And second command is at time 3, move to 0.0. And this is ignored because at time 3, robot is still moving towards 0.5 and is at x equals, I think x equals 2. So yeah, this kind of highlights the mechanic here of some commands get completely ignored if the robot is not ready to receive a command. And immediately you get an insight. A robot is either moving or at its destination. And this is like a simplification. So we get to simplify the condition for ignoring. Not moving, if and only if, at destination. And destination here means the most recent command that it received and did not ignore, where destination is defined as the most recent target it was given that wasn't ignored. So this is a bit of a dense statement I just made. It's like packed with, insight. So let me know if I need to slow down a bit. But this is the first important insight, maybe the only important insight to make. It's a simplification of the condition, which allows you to reduce the amount of state you have to track about the robot over time. Can I move the notepad to the left? Yes, because my face is blocking. Yeah. So yeah, we've realized that the questions we have to answer about the robot to determine whether or not to ignore a command, we can answer those questions, those queries, by knowing two things about the robot. So just keep track of two things about the robot. Where is it? And where is it going? Maintain these two state values over time. So yeah, these are the two things to track about the robot, and that will completely allow you to simulate it. You can simulate your robot just by keeping track of these two values, and also and keep track of the current time. You iterate over events. So yeah. Now the next part of the question is producing the answer. So simulating the robot is one section, one part of the problem, and producing the answer is the other part of the problem. How do you determine if a command was successful? And let's read that section again. You call the command I successful if there is a time moment in the range between ti to ti plus 1, inclusive. If there is a moment in time in that range where the robot is at point xi. So yeah, a command ti xi is successful if current position at ti and next or position at ti plus 1 includes xi. And note that this is not the same as cur at ti and next at or let's just call it cur and next cur. So this is called cur, and this is called next. Yeah, so you're successful if and only if the interval from your current position and the position you will be at time ti plus 1, if that interval includes your destination. This is not the same as cur next includes xi. You may not, although the next command may be ignored and not affect value of next, the condition for success still depends on t plus 1. So yeah, I'm defining ncur to be position of robot at t I plus 1. Yeah, so ncur and cur are the positions of the robots that matter. And yeah, so this should yield a straightforward solution. So solution, compute cur equals an array int, and this will tell you where the robot was. Simulate the robot and record its path. And then read cur I and cur I plus 1 to answer query I. So yeah, the solution is actually pretty straightforward. You use the simulation idea and use that to figure out where the robot was, and then from the insights about producing the answer, we realize we only have to record the path of the robot, which is like the sequence of positions it was at over time. Cabo 25, can you explain statement you write in note section? Yeah, which statement? I wrote a lot of them, so I can try to explain that part in a bit more. How do you store the simulation? Yeah, so the way you simulate the robot is you keep track of the state of the robot and you maintain that state over time. So maybe now is a good time to switch over to my code. So I have my code on the right, my notes on the left. So what we're doing here, this is a bit more complicated than my notes because this is just computing the answer in the same loop. Note diverges from notes slightly. Okay, so yeah, the way I simulated the robot was, first of all, I used long longs just to be safe because the numbers got pretty big. I added infinity to the end of my time so that later I could access t I plus 1 without worrying about array size limits too much. And yeah, I maintained 3 state values. The current position of the robot, which is called cur x, the next position, the destination it has in mind, which is called next, and then the current time. So let's write this down. And then I just processed all the events. So I read in the events as ti and xi. And for each event, I just computed, okay, so how far do I have to travel? And this is a signed number, so I later use that to compute the direction. And then I figure out how many steps the robot is going to take. So it's going to keep going there until it hits it, or it runs out of time. It runs out of time when the next event comes in, because that's how I'm doing the simulation. It's kind of like a sweep. I'm sweeping over time. So yeah, steps is the minimum of the length that you need to travel and the time you have allocated. And now I do my state update. I update cur t and cur x in a natural way. And then I update next. I update next if the robot does not ignore. So this is cur x equals next implies robot not moving. Command received. If robot is moving, ignore command I completely. Don't update next. Yeah, so I use this if condition, cur x equals next, to tell if the robot is moving or not. Because as we said earlier, the robot is moving if and only if it's not at its destination. And that's how we know to update the destination state of the robot. It's going to say, okay, now I'm headed to next xi. And that means for the next time interval between ti and ti plus 1, it's going to be moving towards next. Yeah, and finally, I do some math to compute ncur. This is effectively computing ncur. Okay, over here, I guess. It's checking if, like, first of all, does the interval cur next contain xi? So first check if cur x and next contains xi. And now check that cur x plus sine times ti plus 1 ti minus 1 contains xi. Because it's not enough, as I noted here in this line, it's not enough just for cur next to contain xi. Yes, catching up on chat. How do I store the simulation? Yeah, I hope showing the code kind of answers some questions about the details of the implementation. What is the theme of Vim? Yep, solarized light. Dobby is a free elf. Yeah, it means I'm no longer owned by the Malfoys. We're here, the Malfoys being Ericto. I don't know if you guys know the story, but Ericto, he owned my main for a while. I had to have my main be an alias. It was defined as something like this. And this was because I lost a bet to him. But that bet has expired, which is why I am no longer indentured servant. So yeah, that was problem C. Definitely a lot of observations you had to make and some more insights you had to make to have a clean implementation. And yeah, hope this helped to anyone who struggled with this problem. The actual amount of code is not too much if you plan it out ahead of time and kind of recognize that you only need to track a few variables. Yeah, how so too? It's painful to do contests in the West Coast. Indeed. I'm also in the West Coast. It's 9 a.m. for me right now, and yeah, I wouldn't normally wake up this early, but Codeforces calls. Line 53, in Notepad, yeah, this is just saying that the condition for success, and we can open up the problem statement again. It's like, if there's a time moment in the range ti to ti plus 1, and importantly, it's ti plus 1, it's not what you might think, which is like, by the time the robot finishes its current command. It's by the time the robot receives the next command. And these are two different concepts, because although you might receive a command, you might ignore that command as well. So it doesn't necessarily interrupt the robot's state, but the condition for success is in terms of the time you receive the next command. And that's what this note is saying. What time did I slept pretty early. I slept at like 10 p.m., maybe 10:15. So I got a good 8 hours. Why is the output of the first example 1 and not 2? Basically, it's because of line 53. Because we can go through this. So this was not a success. We did not reach 5 before time 3. And this was not a success. Never reached 0. At time 6, 2.4, success. We eventually hit 0.4 at times 7 received. At time 6, robot is at 5. It's test. Okay, so let's format this a bit. So yeah, this is the sample case, sample 1. You can see that there were 3 commands, and this was received. Time 1, we were at 0, the robot's current destination. Yeah. So yeah, the output is 1, not 2, because only the last one succeeded. I also initially misunderstood the problem and it printed out 2 here, which is why my code is a bit messy there. I didn't think through it ahead of time. I had to adjust in the middle. And yeah, this is definitely the kind of problem you want to use pencil and paper for. Let me show my notes. This is, I actually wrote this stuff all down before typing. I don't know if this is legible, but this is what I do for all my problems. I just write down all my notes, kind of like how I do it in my editor. And I write it all down before I start typing. Obviously, my handwriting is not that clean though, so I don't want to just show this on stream and expect people to understand. It's also written very very quickly, with the intention of maximizing my Codeforces penalty, my score, my penalty. All right, that was problem C. I'm gonna go through problems D, E, and F in a bit, but I'm gonna take a quick water break. So be right back. Hydrate. Yeah, hydration is completed. I have to figure out how to set up my Twitch stream to allow the hydration. Yeah. All right, everyone, I'm back. And yeah, I will upload the stream to YouTube. If I figure out how to do that, it shouldn't be too bad. Yeah, Hausa, you're welcome. Happy to do this. If you appreciate the content that I create, please give me a follow on Twitch and YouTube. That'll make me happy. Will I share my setup? I don't really have a very fancy setup. This is just Vim. I just use Vim to write my code, and then Google Chrome to open up the problems on Codeforces. And I click the choose file button to submit. I do have one trick, which is I always submit from a desktop, and I automatically rename my source files to be prefixed with the directory that they're in. And I can share that. I have this submit function in my Zish aliases, and it copies a file. So I can say something like submit a.cpp, and it creates this a.cpp file. And I also have an alias sub, which basically does the same thing, but it always copies a.cpp. Or first renames a.cpp to the thing. So I can type submit e.cpp or like g.cpp, and then it just gives me a new file called G, which contains my A. And that's so that when I'm coding, I always have a.cpp open, and I just replace this with whatever code I'm writing for the current problem while maintaining, like, making copies every time I submit. So that's my setup. It's not that it's not that impressive. Another thing is I have 3 space tabs because I think the debate about 2 versus 4 is kind of a false dichotomy, and I really want to show that I believe in diversity of setup. So yeah, on to problem D. I don't really remember what problem D was, so let's read it again quickly. Pairs. Right. So you have 2n integers. And you have to distribute these elements into n pairs. After that, take x of the pairs and take the minimum elements of those pairs. And then from the other n minus x pairs, take the maximum elements. And in the end, you'll have chosen n things, and you have a goal, you have a target set that you want to obtain. And the question is about x. This parameter x, the number of pairs that are you're taking the minimum from, how many different x's, between 0 and n, yield a solvable problem, basically. So let me think about this problem. I didn't think about I had a solution for this. I don't remember if it's correct. Okay, so let me maximize my notes. Yeah, my solution to this, honestly, I don't think I proved it. I think it works, but we'll have to see if I get hacked or not, or if I fail any tests. I passed the system test, so hopefully it works. But here was my observation. Let's take the sample input, 5, 1, 4, 5, 9, 10. Sample 2. I'm going to transform this into, like, x's and o's. Where I put an x if it's there and an o if it's not there. And then I'm going to think about this from the point of view of, let's say, x equals 0. So always take max of any pair. And what this means is every time you see an x, it must be the max of some pair. So pair it with some o that came before it. So that means x's are closing parens and o's are open parens. And it's possible to solve if the resulting string is balanced paren string. So yeah, what we're doing here is we're first converting this set of numbers into a one-hot representation, as like conceptually thinking about it as a one-hot string. And then we're mapping it to a sequence of open and closing parentheses in a way that, forms a bijection, basically, between solvable sets and balanced parentheses strings. And yeah, the example we just looked through was for x equals 0, where you're always, for all the pairs, you're taking the maximum elements. Now, what happens when you do x equals 1? Now, one of the x's and one of the pairs, so 1x and 1o, gets flipped. Because now you're taking the minimum. So x must come before o. So yeah, when you say x equals 1, you're basically saying one of the pairs of x and o, you're going to be, it's going to be a minimum pair, which means the number you end up taking, which is the x, because all the x's are the numbers you want to end up with, so elements of b, right? So it means one of the x's and o's is in the opposite order of normal. The normal order is o before x, but one special pair will be x before o. So now let's think about this a bit. What does this mean for parentheses? What does this mean for our transformation? Well, we're still going to be trying to make a balanced parentheses string. So we can actually be a bit greedy here. So greedily flip the first in the string and the last to be open and closed respectively. So yeah, you want to greedily transform your strings to maximize the likelihood, or do something that will guarantee that if the problem is solvable, you'll arrive at a solvable string. So you're not making any mistakes by flipping the first closing paren, because the first closing paren is not helping you, and the last open paren similarly is not helping you. So those are the ones you want to flip. So as you increment x, keep flipping the closing and open. Okay. So let's see what else I wrote down. Okay, yeah, so with these observations in mind, I think we're ready to implementation. So yeah, let's separate these out to observations. So the implementation strategy that I chose was what did I do? Does my solution even work? Honestly, I'm not sure. Geez, I think the solution I submitted is wrong. If you're watching my stream, you might be able to hack it. I'm not going to hack my own solution on stream, but I think the thing I submitted, now that I'm thinking about it a bit more, is not actually correct. This is what I submitted. I just counted the most negative that my thing got to. But this seems suspicious. Okay. You could implement these observations and turn them into a solution that involves, looking at the string from front to back as well as from back to front, kind of considering both extremes. And this is, I think, what Muxcoid in the chat said. You find the minimal x and maximum x possible. Everything in between should also be possible. Yeah, I think that's true. And I don't think that's what my solution does. So yeah, we're just going to move on from this problem. This is a bit not as planned. I was planning to solve all these problems correctly, But accidents happen. So let's just move on to problem E. Plan of lectures. Ivan, programming teacher. Okay. N lectures and topics. He wants to find an order of these lectures to satisfy two conditions. Okay. So, problem E. Two conditions. X crust Z, yeah. Thanks for joining the stream. See you next time. Thanks for tuning in. Is my name of my YouTube channel Stephen Howe? Yes, that is the name. But yeah, back to problem E. Okay, so N lectures, and there's two conditions. Condition 1 is tree order. No child precedes parent. And condition 2. Chained nodes. Xi or yi immediately follows xi in list. Okay, so these are the two conditions, and the question is just to come up with any list that satisfies these two conditions. So the observations I make: 1, chains. You can connect chains. So if you have x1, y1, and then x2, y2, let's use some notation. If these are chained, or let's just call it like A, B, B, C becomes A, B, C. So you can connect chains. It's pretty intuitive. And then 2 is BFS. Is it always possible to have every yi after its xi? Oh, so like the question is, produce such a list, or print 0 if none exists. So yeah, it's not guaranteed that there's always a solution, and you have to print 0 if there's no solution. So yeah, the observations are, you can use BFS, starting with the roots. When visiting a node, in Q, all its valid children and any other nodes, or yeah, that's it. And when visiting, popping off a node, visit it and all nodes in its chain. A node is valid if so it's the root head of a chain, all nodes in its chain, which include itself, are ready. My parents have been visited before. And special case, if a node's parent is in the same chain and earlier, treat it as visited before. Okay, so these are the 3 observations basically. I'll take some questions because this problem involves like a lot of like different observations, and I don't want to go too much into detail on any particular one. And I imagine not everyone is too interested about this problem, so I don't want to spend too much time on it. I'll pull up my code. Unlike problem D, I think I got this one correct. So zooming out a tiny bit because my code is kind of long. Yeah. Let me know in the chat if you have any questions about this problem. It's kind of not something I remember super clearly at this point, but these were the three kind of observations I used, and that was enough to come up with a solution. I hope I got it right. I was a bit messy for sure. Like, I think the special case, the way I handled the special case was very like, I handled this in the drink way, but I think it doesn't cause issues. Yeah, basically, I would call hit on a node whose parents might be earlier in the chain, which would increase its counts, kind of double counting because it's been increased before, but fortunately, it is not an issue. Problem E is not really path. Yeah, I guess it's like a path finding a path through a graph, but the path does not have to be like along the edges or anything. It's just like you can jump around nodes. The only condition is you don't visit a child before its parent, and that you satisfy, like once you hit a chain, once you start it, you go through the entire chain. And that's kind of condition 2. You're given a list of pairs xi, yi, and yi must follow xi. But yeah, let's quickly move on to problem F. Is cycle possible in this problem? Yeah, cycle might happen. So at the end at BFS, if not everything visited, output 0 will happen if there's a cycle of dependencies, either within a chain. So if a single chain is cyclic, that will cause you to not visit everything because those will never be ready. Those will never be valid because, you know, nodes in that thing will always have parents that aren't visited, or involving multiple chains. Or you might have two chains that are interdependent. Two chains might depend on each other, which is like a cycle at a higher level, a cycle between multiple chains. Okay, sleep is sheepy. How do you determine the start of a chain? How do you represent the graph? Okay, yeah, these are great questions. These are some implementation questions that I'm happy to answer. So, I read in the input into my array called par. P-A-R stands for parent. That's how I represent the graph, with par. I also come up with a parallel representation of the graph, which is an edge list. So, two representations of graph, par array and edge list. And yeah, do I need to zoom in here? And yeah, I maintain two different representations because it's very cheap to do so and it's useful. And then, how do I determine the start of a chain? Yeah, representation of chains. The way I did it was first read input as chain next, chain prev, to set chain next. So chain next is just what is the next node in a chain given x, because every node is part of at most one chain. I initialize that to -1. Initialize to -1. And the way I find the starts of chains is I check if chain creeve equals false. I is the head of a chain. And then I just go until you hit -1, at which point -1 is the end of a chain. So that's how I represent my chains, or at least it's how I use the input to compute my chains. I actually represent them, then construct list of chains. So chains I is list of nodes in chain I. Yeah. And this is an ordered list. What is the complexity? How do you prove it's not n factorial? I mean, you can look at the complexity just by counting kind of the for loops, or like thinking at a higher level, just like all these processes are linear, basically. This is an O of n solution. All we're doing is like moving pointers around, vectors of vectors, whatever. You're just indexing into arrays, etc. Let the game begin. Your implementation is awesome. Thank you very much. I'm very proud of my coding skills. I think this implementation probably could be simplified, but yeah. You tried to hack my D, but you think it's correct? Well, that's a shame. Maybe it's not actually wrong. We'll see. I don't remember enough about D. I just remember being somewhat confused while implementing it. So we'll see if it's right or wrong. Craft mechanics, will DFS yield a correct solution? Interesting question. I don't know. I don't remember how to do DFS. I think it will, honestly. I don't think there's any reason I had to do BFS over DFS. It was just a bit easier for me to think about in terms of BFS. But yeah, I don't think there's any reason you can't do DFS here. Yeah, so I'll write that comment here. Could have been DFS, but this felt more natural at the time of writing. So yeah, I'm pretty sure DFS would work as well. There were several hacking attempts and they all failed. Oh, I'm sorry for baiting you guys. I was legitimately suspicious of my D. I'll say that. It was honest. I would not have been surprised if it got hacked. Though I still wouldn't be that surprised. Maybe you guys just haven't come up with the right cases. But yeah, this is problem E. This is my implementation. I store it. Yeah, the important thing is come up with your representation first. Make sure your representation is enough to answer all the queries you need to do. Then just write the code to do it. Once you've had enough practice with graph theory problems, like, you'll just know which representations are available and possible to do. Okay, finally, let's move on to F. Quickly go through F, and then maybe I can go back to D and figure out why I was so confused. Max correct set, definitely the hardest problem, took me the longest time as well. Take a look at my submissions. Only 4 people solved this problem. We have Dream Moon, Hino, Stephen K. Plus, Geothermal. Oh, what order is this in? I don't know what order this is in, but in the contest, the top 3 people solved F. How do I see the hacks? No one doesn't say who hacked it. But yeah, not very many people solved F because it was, a very hard problem. Let's read the problem statement together. Very short. F. Given n, x, y, find maximum number of size of set in that has no two elements that differ by exactly x or y. So yeah, f is a very short problem statement. You're given three numbers and you want to print out a number. And yeah, I guess I'll go through observations. Not all relevant, or these are not all going to be useful. But one, if x, y both odd, you can always pick 1, 3, 5. So the answer is like n plus 1 over 2. So that's the first observation, is you can always pick numbers of the same parity if x and y are both odd, because then your differences are guaranteed to be even. And 2, if x, y not both odd, you cannot, there is no equivalent trick. And 3 is answer is always like O of n over 2, upper bounded, O of n over 2, because of reasons. Because for each m modulo, like, yeah, for each, let's say from 0 to m x, you can consider the sequence m plus x plus 2 times x. So you get x sequences, and within each sequence, you can only take at most every other element. So in total, it's approximately half. So yeah, these are the three, I guess, level 1 observations. These are not too hard to make, but they don't lead to any solution. And I guess 4 is like, you can use bitmask dp to solve the problem up to n equals like 100. This is O of 2 to the n times, or this is O of 23, 2 to the 23 times n. So yeah, insight 4 is the only useful one. Note. And then finally, here's the big insight. If x and s sorry, a truck just passed by, but let x be max on of s, and or I can't use the word x, m, then m plus x plus y can be added to s. Because m plus x, m plus y already forbidden. What is ELT? ELT stands for element. Yeah, n can be below x and y. They're all unrelated numbers. Yeah. In which case the answer would just be n. If n was less than x and y, you just take all of them. So yeah, the insight 5 that I made was basically, if you're going to take a number m, then you can't take m plus x or m plus y. But that kind of hints to you that you should just take m plus x plus y, because they kind of are symmetric in that they're both connected to m plus x and m plus y. So this strongly hints at the hypothesis that the answer S will be periodic with period x plus y. In other words, take I if you take all I. Well, let's just say I plus x plus y. I don't know how to prove this, honestly, but I believe there is a proof. I might have come up with a proof during the contest, but I didn't have that much time. I spent a lot of time thinking about this problem, so by the time I realized that this might be the answer, I only had like 5 minutes left. So this is what I submitted, or this is what I used in my final accepted submission. It is probably true. I don't have a proof yet. And yeah, the way I implement this, and thanks Geothermal for the compliment on my on the code style here, is I assigned a weight. Yeah, proof by AC. That's right. I assigned a weight to every number modulo x plus y, and that weight is the number of times there is an element between 1 and n. So okay, there's vowels I equals number of m between 1 and n, such that m mod x plus y equals I. Vowels I is a count there, because I'm depending on the fact that all I have to do is pick kind of within the question is just asking, pick a set of numbers between like 0 and x plus y, such that you pick those numbers, all those numbers, their entire equivalence class is modulo x plus y. So question, pick a subset of 0, x plus y, so that if you pick I, you take all the entire equivalence class I modulo x plus y. And don't violate any of the conditions. And yeah, you're guaranteed that this, like, if you can pick this subset, that this subset is valid. Like, as long as there's no I comma j in the subset where x plus I equals j, or x plus y equals j. And you don't have to worry about the wraparound. Like, that's not something that you need to check for explicitly. Like, given I less than j, you can take I and j if I plus x not equal j and y not equals j. Note that this implies j plus x not equals I, j plus y not equal I, because numbers are modulo x plus y. So yeah, this is the key insight for this problem, which is like, you're allowed to do this subset thing. And yeah, I don't have a proof for why you always want to do it, but it seems natural that you should. And the way I implemented this was with like a bitmask DP that I iterated x plus y times. The DP was basically for this given mask, the mask being like a representation of what numbers you've taken so far. in this x plus y equivalence thing. What's the maximum value being sum of the values of the things that you chose? What's the maximum sum that you can attain? And at the end, you just print out the last dp value. So yeah, that's it for problem F. I don't think I did the best job of explaining it, and I, don't have a complete solution mathematically because I didn't prove it. There's probably going to be an editorial, so look out for that. And I'll probably need to read that as well. But yeah, that is my F. And happy to take any questions if there are any things that you want me to go over again. But I do need to sign off in probably a few minutes. I have a job I have to go do. Yeah, I got a question. When you were like really beginning and had knowledge of standard DSA, what was your method of practicing? I'm still only able to solve till B. Okay, yeah, to practice Codeforces, I think just take the problems you can solve and really try to understand them deeply, and then take the problems that you can't solve but you feel like you should be able to solve, and try to figure out how to, like, what you're missing. Read the editorial, etc., and try to figure out, like, what is it that you didn't realize? And, like, is there an observation you missed, an insight you missed, or is it just like the implementation you didn't think about clear-headed enough? Like, try to identify your weaknesses and then find ways to improve. And yeah, it takes a lot of time, takes a lot of investment. Just, you have to be have the right amount of dedication to put in the hours and really practice a lot. I think that's the answer. Thanks for the stream. Yeah, no problem. Always happy to just help people learn and improve. I'm pretty new to streaming, so this is also, I think, a growing and a learning experience for me. If you have any feedback on my streams, I'm always happy to hear it. Post it in the chat or DM me or anything. Yeah, thanks for your notes while explaining, super helpful. Okay, glad to hear that my notes are helpful. I could try to write this in a more organized or rigorous way. I think diagrams probably would be helpful. I'm considering buying equipment for doing diagrams online. Binarysearch.com weekly contests. Haven't heard of this website. Learning algorithms together. Sure, sounds fun. I'll keep this in my to-do list. Maybe one day I'll get to it. Bookmark it. Okay, well, can I share these notes? Yeah, what's a good place for me to put these notes? I'll put these in a comment on my Codeforces post. Thanks for the suggestion. So, where is my... Oh, I didn't make a blog post. Okay, yeah, I'll make a gist. Posting it to gist. Oh shit, I lost it. Okay, I'll find my gist. Yeah, so here's my gist. Codeforces EDU round 100 notes. Yeah, this is this is not Markdown, so I'm just gonna put in a code block. Oh, okay, it's already not Markdown. Okay. So maybe I don't need that. But yeah, I'll post this in a comment on Codeforces. Thanks a lot for the suggestion. How do I reply to this? Raw notes on problems A through F. Live learn stream. YouTube video will be posted on, well, that's the link again, my channel. Okay. Cool. Great. Thanks all for tuning in. Final question, why did I choose to work on a company instead of doing research? I just wasn't that interested in doing research. It seemed like it was not as fun, and I don't know if that's like where my passion lies. Like, I definitely like solving problems and thinking about technical topics, but I think I can't do it for a living. At least not in the research dimension. All right, thanks everyone. See you next time, and good luck with all your practice.